Okay, today's video is the Unit 3 test review. And I'm just going to dive right in. So problem number 1, list all the factor pairs of 108. So we're going to take 108 and we're going to start with 1 and 108 because 1 times 108 is 108. Then I'm going to grab my calculator and I'm going to do 108 divided by 2 and find out that we have a factor pair 2 and 54. Literally just grab your calculator, do 108 divided by 2. You find out that that's 54. That means 108 is 2 times 54. So I have another factor pair, right? 2 times 54 is 108. So I list 2 and 54 as one of my factor pairs. And I'm just going to go through the list of numbers. 1, 2, 3, on and on I go. 108 divided by 3. Yep, it comes out to a whole number. 108 divided by 3 is 36. 108 divided by 4, does it come out to a whole number? Yes, it's 27. So 4 times 27 is 108. We want the whole numbers that multiply to create 108. Is 108 divisible by 5? Nope. By 6? Yes. 6 times 18 is 108. 108 divided by 6, you find out it's 18. Is 108 divisible by 7? Nope. By 8? Nope. By 9? Yes. 108 divided by 9 is 12. And is it divisible by 10? No. By 11? No. By 12? Yes, but 9 and 12 are already there. So there's my complete list of factor pairs for 108 when my factors need to be positive integers or positive whole numbers. Okay, number 2. Find a pair of integers that multiplies to negative 42 and adds up to 1. So I'm going to list the factor pairs of 42. 1 and 42, 2 and 21. Is 42 divisible by 3? We grab a calculator and we find out it's 14. 3 and 14. Is 42 divisible by 4? Nope. By 5? Nope. By 6? Yes. 42 is 6 times 7. Now what I need to think about is when I have a product of two integers, if I have a pair of integers that multiply to create negative 42, one of them is going to have to be positive, one of them will have to be positive, and one of them will have to be negative. But if I need them to add up to or sum to a 1, the negative is going to have to live with the smaller number. So I'm going to look at my factor pairs, negative 1 and 42. Let me just write them over here. Negative 1 and positive 42, that sum is 41. That's not it. Negative 2 and 21, that sum is 19. Negative 3 plus 14 is 11. That's not right. Negative 6 plus 7, there it is. So my factor pair, my two integers that multiply to create negative 42 and add up to 1 are negative 6 and 7. Problem number 3, what is the GCF of 42 and 90? So I'm going to take the 42 and I'm going to break it down as a product of primes and do a little factor chart. 42 is divisible by 2 because it's even. 21 is what I come up with. 21 is not prime, so I'm going to, let's see, I can't divide it by 2, but I can divide it by 3 because 21 is 3 times 7. So my 42 is 2 times 3 times 7. And then I need to do the same kind of thing with 90. So I'm going to do a factored chart for 90. It's divisible by 2 because it's even. 90 divided by 2 is 45. 45 is not divisible by 2, but it is divisible by 5. 45 divided by 5 is 9. 9 is not prime. It's 3 times 3. So my 90 I can write down as 2 times 3 times 3 times 5. There's my prime factorization for 90. Now I'm going to compare those and see what they have in common. Remember, GCF is greatest common factor. So we look at the 2 they have in common. We look at the 3 they have in common. And the GCF is going to be the product of 2 and 3. So 2 times 3, but I'm going to write it as 6. So my greatest common factor is 6. 6 would be the largest whole number that divides evenly into 42 and 90. All right, for problem number 4, what is the greatest common factor for the following monomials? Now notice the commas right there and right there. We've got this monomial, and I'm going to let you guys work out the 24, but I'm going to write in its prime factorization. 24 is 8 times 3, but 8 is 2 times 2 times 2. Go through the process that we went through over here to get those. Just practice it. So there's my 24. My m squared is mm. My x squared is x times x. So there's my 24 m squared x squared. I'm going to do the same thing with my 16m to the third. Okay, so my 16 is 2 times 8, but 8 is 2 times 2 times 2. So there's 16. Or you can look at it as being 4 times 4, and then each of the 4s is 2 times 2. And m to the third is m times m times m. Then I'm going to take the last one, my 52 mx to the third. 52 is 2 times 26, but 26 is 2 times 13. So there's my 52. Then I have a single factor of m, but I have 3 factors of x. Now look at what factors they have in common, because we're trying to find the greatest common factor, GCF, greatest common factor. So they have a 2 in common. They have another 2 in common. Do they have another 2 in common? Nope, because my last one has a 13. 2 times 2, and then what variables do they have in common? An m. Do they have more? Nope, that's it. So my GCF is going to be 2 times 2 times m, but I'm going to rewrite that as 4m. So our GCF is 4m, and we're done. Okay, we're going to do a problem where we have to factor out the GCF. So when we say pull out or factor out the GCF, first thing we have to do is find the GCF. So let's find that GCF. So 6, 15, and 27, what are they all divisible by? They're all divisible by 3. And again, you can do what we did in problem number 4, looking at the 3 terms of our polynomial and find their GCF that way. 6, 15, and 27, we're going to find out they're all divisible by 3, but nothing bigger. 6 is 2 times 3, 15 is 3 times 5. They have a 3 in common, nothing bigger. 27 is divisible by 3. So the GCF is 3. That's the first thing we have to figure out. Whoops. They also have an x in common, don't they? Right? This one has 3, that one has 2, that one has 1. They have an x to the first power in common. So 3x is our GCF. So what I'm going to do is I'm going to look and see what happens if I divide a 3x out of each of those pieces. So 6x to the third, if I divide it by 3x, what remains? The 2x squared. 6 divided by 3 is 2, and if I take one of the factors of x, that leaves 2 over here. Minus, we're going to take the second term, write it as 3x times 5x. 3 times 5 is 15, and x times x is x squared. And the last one, 27 divided by 3 is 9. Whoops, let me write down the GCF first. 3x. 27 is 3 times 9, and I've already got the x out there with my GCF. So there's what we can do. We can write each term as the GCF times something, some other factor. And then we pull out the GCF, which is undistributing. So we have 3x times, in parentheses, 2x squared minus 5x. Every one of these, I'm pulling out the 3x. So what's left is the 2x squared, the minus 5x, and a plus 9. And we're done. And I think I'll stop here with this, and I'll do a second video for the back page. Just make my 5 look better. And here we go.